So, here we go. Do you remember doing these? Oh, did I run out? Did everybody get one? Okay. Do you remember doing the mixture problems earlier in the year? Amount times percent plus amount times percent equals amount times percent. Okay, so we're going to review those again. That's the review part. Everybody should remember. So we're looking on page 23, problem number 1. How much 12% orange juice needs to be added to 5 gallons of 15% to get a 14% solution? So I'm going to write down amount times percent plus amount times percent equals amount times percent. Okay, every time we have a mixture problem, I want you to start with this format. Now, the percentages are all there, so let's fill those in. We're going to mix together a 12% and a 15%, and we're going to end up with a 14%. Does that make sense to everybody? Now, where do I put the 5? It says needs to be added to 5 gallons. So the 5's going to go here. Everybody good with that?
Yes.
Now, how much 12%? Can I put X here?
Yes.
Because that's what I want to know, right? How much of that? Now, here's where things get tricky if you're not thinking. You're going to mix X gallons and 5 gallons. How much are you going to have all together? X plus 5. Very, very good. Okay, everybody on board? So we've got 0.12x plus, okay, you got a calculator, 0.75 equals 0.14x plus 0.70. Is that right? 0.7. Okay, so I'm going to subtract this over here, and I'm going to do this very carefully. 0.14 minus 0.12 is 0.02. Don't say 0.2, it's 0.02. Then when I subtract this 0.7, I have 0.02x equal to 0.05. Then I'll divide by 0.02, and x equals 2.5, and the unit on that would be gallons. Hopefully that's ringing some bells, because we did some of that earlier. All right, let's try number 2 now. It's the same sort of thing. So I start by writing amount times percent plus amount times percent equals amount times percent. Okay, what are my percentages?
54.
I have 54%, and I'm mixing that with some 84%, and I'm going to end up with some 60%. Now, do I know any of the amounts?
54.
8 cups, so I'm going to put an 8 here with the 54. Is that okay? You see that in the problem? 8 cups of 54 is mixed with some 84%. Do I know how much of that I have? No, I'm going to call that X. What am I going to end up with then, kids, if I mix 8 cups with X cups? 8 plus X cups. Now I need your help with the calculator. What do I get here?
4.0.
Thank you. Plus 0.84x equals 0.60x. Well, I'll do it in the right order. Is that 4.8 plus 0.60x?
Yep.
So I'm going to subtract, so I have 0.24x equal to 0.48. Double check my arithmetic. So x equals 2 cups. Now, is there anybody that has a question about something that's going on up there? You have a calculator, so don't let the arithmetic bother you. Kaylin, you okay this morning?
Yeah, I have a headache.
Oh, do you want to go to the office and get an aspirin?
I've taken aspirin. I think it might be sinuses.
I'm sorry, that stinks. Usually math makes us feel better, so maybe that is. Okay, number 3. Now, this is a different kind of problem. I want you to read number 3, and I want you to notice we are not mixing things.
Did you go to the game Friday?
Yes?
No.
Actually, I heard them say your name on the PA. And I'm sure as you were thundering over that poor kid, you were... Okay. All right, number 3. Everybody recognizes this problem's different, right? Okay. If it's a mixture problem, we're going to use the setup amount times percent plus amount times percent equals amount times percent, and that will always get us in the right direction. In one of these problems, which we call work problems, because what's happening is someone's doing a job and somebody else is doing a job, and together then they do the job. These are called work problems, and the general formula is 1 over the first person's time alone plus 1 over the second person's time alone will give you 1 over their time together. So let me show you how this works. We're going to use 1 over alone plus 1 over alone equals 1 over together. So in this problem, Danielle can do it in 4 hours. So I'm going to say 1/4. That's Danielle. If Zach helps her, it will take them 3 hours. Okay, now wait a minute. Zach is helping Danielle. So that's over here. That's together. It takes them 3 hours. How long does it take Zach alone? So here's Danielle alone. Here's Zach. Here's Zach, which we don't know his time alone. And here is their time together. Now notice it's 1 over. So it's 1 over 4 plus 1 over x equals 1 over 3. You just took a quiz where you had to solve an equation like that. What am I going to multiply by that will make all the denominators cancel out? 3 and 4 and x. So I'm going to multiply everything by 12x. 3 and 4 and x. And the reason I do that is so that I can cancel out all the fractions. So what do I have left here?
4 times x equals 40.
Watch it now. 4 goes into 12 3 times, so this is going to be 3x. Katie, this is going to be 3x.
Yeah.
And the x's are going to cancel, so plus 12
Plus 4x
equals 4x. So 12 equals x. That's it. 12 equals x. And that would be x, or 12 hours.
Wait. Dang. Wait, that doesn't make any sense then.
What doesn't make sense?
Well, if one takes 12 hours to do homework and the other takes 4, how do they get 3? How does it take you 12 hours to do that?
Yeah, let's take a car to your homework.
That is an even better question.
Okay, next.
Wait, this problem doesn't make any sense.
Here we go.
It's not that.
Grant can paint the football field in 8 hours. Okay, so we have 1 over alone plus 1 over alone.
Equals 1 over together.
Equals 1 over together. So here we go. What do I do with the 8 hours? That's Grant alone, right? Matt can do it in 6 hours.
1 over 6.
So that's going to be plus 1 over 6. How long will it take them to do it together?
6. 1 over X.
1 over X. Okay? Now, we need to multiply to clear the fractions. Now, this is the first time this has happened to us. Let's not panic. It really doesn't matter what you multiply by. Some of you are going to say, I'm going to multiply by 8 times 6 times x, and that will work out fine. But you really don't need to multiply by that big of a number. You could multiply by 24x. Your goal, kids, don't be confused. Your goal is to get rid of the denominators. So what will cancel out an 8 and a 6? Certainly 48 will do that. So if you want to use 48, use 48. But won't 24 also cancel out an 8 and a 6?
Yeah.
It's the idea of the least common denominator. Not just a common denominator, but the least. I don't care. It doesn't make a difference. Use 48, use 24, you're going to ultimately get the same answer. So 8 goes into 24 how many times? 3. So I'm up at 3x. Plus 6 goes into 24 4 times. Left with 4x. Equal 24. So 7x equals 24 and x equals 24/7 hours. That's okay to leave it like that. Now let's look down right underneath there, problems 3 and 4. I want you to look at problem 3 and I want you to look at problem 4. And then I want you to decide which one you can do on the board. And I want both of these put on the board by someone or a team. But I want to see 3 and 4 done up here on the board. We'll put 3 here and 4 here. So, let's not all just dash up here at the same time. Who's going to come up and do this?
I'm almost done.
Which one can you do?
I'll do
I
it.
can do it if you really want.
Of course I want you to. I want you to say Katie up and do it with Katie. Okay? Hurry up, pick.
I'll do number
let's
4.
do 4.
I'll do number 4.
Sorry, Jabron.
I'm sorry, you're not at the board yet.
Or should we do 3?
You guys can do 3. All right, let's go. Let's go. Everybody's doing this.
Yes, math. Yes, it is.
No, it wasn't.
Okay. Why are you sitting there?
I'm sorry. She freaked out. Basically, I don't know what I'm doing. He sent me a video of me standing on the table.
I put the piss in plastic bags.
Wait, this is what?
No. The mouse trapper.
Yeah, Javon.
I'm actually like being serious.
I'm being serious too now. You don't remember. You know you don't want to do it. You don't really want it. Karen did. You want it.
How bad do you want it?
I'm never making cookies again.
Really, Kieran? No, it's so crazy. Yeah. Well,
Abby, you won't go get another cookie? Throw me one. I'm too scared.
Okay.
You're also scared.
Okay.
No.
Oh, okay, that's what it's
Okay. Okay. What's next?
You subtract.
Remember last year?
I got you.
You got it.
I got you, dog.
Those are so bad. I don't know what. No, the one that we did.
Okay. I'll subtract that.
It looks like sugar.
Oh, 0.16x plus 0.9 equals.
Subtract. No, not that. Yeah, 0.16, you subtract that.
Where did you fly?
Point.
What time are you
Negative point.
Oh my gosh.
Okay, how we doing? Ron, you got done?
Oh gosh.
I mean, Mitch, what are you doing? That's not.
When it's Heidi, we got home this weekend.
No, that's what
No, wait, you missed. Look at my college. Good. Was she not married?
So what?
She applied to really. She hasn't gone to school. Oh, so she's been gone the autumn. Hi. It's so cute. It was chubbier than I expected. I expected she was just tiny. It was that point today. Oh yeah, I saw it. It wasn't like you like going this point. The one that was. Yeah, you're not eating. The one that was. What are we doing? We did like easy cream, and you do that.
This
Which I have 1.5. This is cream. On red. Yeah, on these points.
Track.
Damn. That's a 3. Damn. 145? I feel Libby's Sanderson can only get like that.
So then we're gonna subtract the point.
That was just a 3. What'd you get? I hope you gave me none. I get like 1. I've had back squats and non-gravity. Now, that is awful. How much do you get? It's not good. I think I saw that. I don't understand how you can squat that much. You're so small.
All right, boys and girls, let's take a look at this, these two, and see how you did. These will be test questions, so we want to make sure we understand them. Tonight's homework, we're going to do some of that. So here we go. First problem with a nice little heart. 1 over alone plus 1 over alone equals 1 over together. So they said 1 over 4 because Amelia can paint the room in 4 hours. This is Amelia. Plus 1 over x. That's Erin. We don't know how long it takes Erin by herself, but we know together they can do it in 1 hour. Now, they wrote just a 1, which is absolutely fine. Some of you may have written 1 over 1. That's the same as 1. So then they multiplied through by 4x. and did their arithmetic and got 4/3 hours. Now, you were supposed to be doing that at your seats. Did anybody have a question? Now, Gibran had the mixture problem. He didn't write down his general formula, so I'll write it down. So Gibran said, how much 16% should be mixed with 9 quarts of 2% to get a 10% solution? He set it up absolutely perfectly. Yeah. Good work. Good work. Does anybody have a question about either one of those? In your notebooks, I gave this to you a long time ago, and I believe when I gave them to you, I can't remember if I had them stapled together or not, but you have something called Precal C word problem worksheet. 2.6, 2.8. It is typed. It's typed.
Is it in a packet of stuff?
I can't remember. If it is, it's stapled just to one other thing.
Oh wait, no, is this?
Okay,
It wasn't stapled.
it wasn't stapled. Okay, this is a free paper. It was not stapled.
This, Julia?
Yes. Yes.
No, it's not stapled. It's
No,
not.
no, no, no. It's not stapled to something. It's a
Yeah.
plain
I
paper.
feel like a cookie or I just applied just because I think I'll get it. Oh,
Look at it. Look at it.
Come on, Liz.
Look at it.
It's in Mississippi. Thank you. I have no idea. I can't
Look at
find
it.
this. I don't even want to try to find it. I found it.
It's a word problem.
Carolyn, what's your when do you find out? Yeah.
Okay, so everybody's found it? No, everybody has it. I gave it to you a long, long time ago. Everybody has it. If you have lost yours, simply take a picture of someone else's.
Yeah, okay. You can have a yeah, that's all right. I feel really weird right now. Like dizzy, like you like light and then I feel like that. Always in the physical wall that is to transfer your second. It's like a real
Especially how much work it is.
I used to do
Okay. I handed these out a long time ago, so if you are not organized, you probably don't still have it, or it's somewhere along. Take a picture of someone's. This sheet is your homework tonight, so you need to take a picture of someone's. There are only 7 of them. I threw a curveball in. Number 7 is a curveball. So I need to look at number 7.
Are you giving us the rest of class to work on this?
What?
Are you giving us the rest of class?
No, I'm not getting the rest of the class to work on these. We've got work to do. I'm going to do one of them for you. You only have 6 problems to do for homework. Okay, let's look at number 7. Some of you are thinking, well, Ms. Ford, this isn't fair. You told me that the problems would all be mixture problems or the work problems. In other words, amount times percent plus amount times percent. or 1 over a loan plus 1 over a loan. So what is number 7? Can anybody see?
It is a mixture.
It's a mixture problem. The only difference is, instead of having percentages, we have money.
So do you turn it into percentage?
But it works the same way. So we're gonna have amount times percent plus amount times percent equals amount times percent. Only instead of percentages, I'm going to put $3 and $7 and $4.50. The strategy is going to be exactly the same. Think of the money as the percentages. So here's $3, here's $7, here's $4.50. Now, where do I put the 10?
7.
It's with the 7, it goes right here. What do I do with how many pounds of peanuts? That's X, right there. That's X is peanuts. And 10 is cashews. And then how much nut mixture am I going to end up with? X plus 10. Okay, so we have 3x, I don't need all those decimal places, plus 70 equals 4.5x plus 45. Now, I want to make sure everybody's got this equation. Is everybody good with this? X times $3 plus 10 times $7 equals X plus 10 times 450. So now I'm doing my arithmetic. I got a calculator, so it's not an issue. 1.5x equals 25. And what does x equal? So 16.66. Repeating? And the unit on that would be pounds. Now, are you okay with that, kids? It's done just like a mixture problem, only it has money in it instead.
I like my English.
That's good.
My senior quote was,
It wasn't Precal stops for no one?
no, that was a close second.
All right, we have one more thing to do today, kids. Let's go back to our note sheets because there's a couple problems we didn't do and we need to do that. Hopefully we can get one done. Go back to your note sheet, page 23. Oh, by the way, that sheet that we were just working on, that's homework tonight. So you got 6 problems. Set that aside for a quick moment. Go back to your note sheet. Hey, just move the Go back to your note sheet. Problem number 23. Or page number 23. I'm sorry, page 23. We have not done number 10 or 11, have we? At the top of the page there? We need to do those. Okay? I promise that tomorrow we will review and I won't be so discombobulated here, kind of doing all kinds of different things. But we got to kind of wrap up today. So, I'm looking at problem number 10. I need your complete and undivided attention, Abby Grady. I need you writing this down. This is problem number 10 on page 23 of my notes.
Wait, I don't need to write it down because it's already written.
Yes, but now I need you to work along with me. Okay? Now, we've not done one like this before that had a 4 in this spot. Step 1,
I'm never doing my expense.
subtract 4. Now, kids, I don't very often tell you that you have to do a problem in a certain way, but I'm telling you now. Step 1, subtract 4. Step 2, get a common denominator. Now, this doesn't look like it even has a denominator, but it does, right? 1. So we need to get a common denominator. This is a subtraction problem. We need a common denominator. The common denominator between x minus 3 and 1 is x minus 3. So this fraction already has x minus 3 as its denominator. This fraction needs it. So I am going to multiply the top and the bottom by x minus 3. Kids, if there were a shorter way to do this problem, I'd be doing it. There isn't one. You need to do what I'm telling you. Step 1, subtract 4. Step 2, multiply top and bottom here by x minus 3. So now you have the fraction 4 times x minus 3 over x minus 3. Both of these fractions have to have the same denominator. This one didn't. Now it does. Now I can write them as one big giant fraction. Since the two denominators are equal, I can write this as one giant fraction. It would be x plus 2 minus 4x minus 3. Right, take a look at what I have right here. See how they're both over x minus 3. So I can write them as one fraction. So I have my x plus 2 minus my 4 times x minus 3. Now guess what I'm going to do up here? I went ahead and did my distributive. So now let's collect like terms. What do I have up here? Negative 3x plus 14. Is that right? So now it looks like you don't remember probably because it's been a few days since last Thursday. But now it looks like the problems we did on Thursday. It didn't in the beginning because it had a 4. It can't have a 4. It must have a 0. Now it has a 0. So I'm going to draw my number line, and I'm going to put 2 dots on my number line. One of the dots will be at 3. Would you agree with that? This dot's tricky. To find out where to put that dot, I'm going to do negative 3x plus 14 equals 0. I'm going to figure out where to put that dot. So I'm going to set that equal to 0 and say, okay, that dot must be at 14/3. This problem's a lot of work. What's 14/3 in terms of a number? 4.6. So if I'm putting my 2 dots on the number line, I'll put 3 here and 14/3 here. Anything odd about the number line I just drew? One's open and one's closed. That's strange. Can anybody explain that to me? Olivia?
Because 14/3 is like greater, so like obviously everything that way is gonna never mind.
We'll continue this tomorrow. Your homework is those 6-word problems. Have a wonderful day.